So the method that you're building is inside of a class called sound. And sound has a property, just like you have a property in your human class of your name. This sound has a sample. That's basically all of the an array of volume that indicates the sound. So just the amplitude. This is essentially the song, and this is the equalizer readout for the whole thing, being kept in some sort of integer array. It's make-believe, but let's go with it. And so in this method, we want to iterate through or over this integer array and apply the given limit. So let's look at this first line that you wrote here. And this is absolutely correct. So if you're creating a new integer array, this is giving a property, a scoping value, privacy setting, because it's being declared under a class and not inside of a method. And so we're setting the properties on how this works for an instance or an example of a sound object. And so you don't need that inside a method. So this is correct. You're just saying I declare an int array called amps, but I think you're creating one by mistake because you don't realize that the sound is this.samples or just samples. So we can access it from any method because it's a part of the class variables. And so we don't need to create this at all. And just to point out, you wouldn't reuse the name. You've already declared the name here. So we just say, I want a new integer array of however, you need to give it a size if you're going to do it like this. So a new integer array of x size. Because they're immutable, you can't change the size later, so you got to get that right. And so you need to figure out. Or you can just declare it and not initialize it. And so you can just declare it, hey, I'm making an int array called amps. Not set to anything yet. You can't use it until you initialize it. So down here or later on, you could set it equal to an array of numbers if you wanted. So this is a literal array. This is literally an array. And I'm storing it inside the variable here that I declared using this statement here. So declaration statement, initialization statement, literal object. Just like this is a literal string that says literal. Just to really beat this dead horse. Okay, moving on. So we can just strike that whole line, and we don't need that. So now we can iterate through samples, or this.samples. And that just says this instance of a sound, give me my samples. So I'll iterate through that. I don't need this counter. Yeah, so let's strike that. And now amp doesn't exist. This is our iterator. Let's just call it num to make it easier. Our number is going through or iterating all of the samples in my song. So if my num, hold up. If my number here, it pastes it, doesn't replace the object. Anyway, it behaves a little differently than I would expect. If my number is greater than or less than the negative limit, we can use an absolute value if we wanted to. So math.abs or absolute value. And then use this as a parenthesis. That way we would get the absolute value to see if that was greater than or equal to the limit. And we only care about greater than because you're setting it equal to afterwards. So if it's equal to, you don't need to make a change. But if it is greater than the absolute value of the current thing, if that's greater than, but then how do we set it whether or not it's negative or not? There's probably a simple math thing that's not coming to mind real quick. Well, it's been a long day, so I'm just gonna, we'll do this. This is not as efficient as it could be, but it's simple and it makes sense, so that's not bad programming. So if num is bigger than the limit, the number, this part of the song, then we set that part of the song equal to the limit. Oh, but we have a problem here because we're using a for each loop. And when you use a for each loop, this num is just a copy. If we change it, it doesn't actually change the part of the song that we want to limit. And then the kids wearing their headphones too loud are going to get their ears hurt. So we need to use a traditional for loop. Bam. So we have int I equals 0 as long as I is less than the samples.length, and we really don't need this. If it doesn't see a local samples being declared here, Java is smart enough to say, oh, well, if there is no local samples variable declared here, let me go up and see if I have one inside my class object. And so lo and behold, it'll find it. So no big deal. Samples.length, I++. Okay, so now num doesn't exist, so instead we just do samples at I. So the reason why we have to do that, because now we're messing with this directly, not just through an iterative copy. Instead, we can now update that. So just replace this, boom to boom, and we're all set. We don't need to return anything. We need, yes we do. What are we returning? Oh, got it. Yeah, the counter of how many things you changed. Okay, so int count equals 0, and if you need to return a counter, start the counter, return the counter. First thing, I should have caught that. Classic point to make. If the mission of the java.comment says return a counter, so start the counter, return the counter, boom, and then each time you make a change, count plus. So make update and counter, shabam. I think this problem is done. Cool. I probably shouldn't have gone through and finished it entirely. Left some mystery for you. So, but anyway, you have to type it over. So there. Okay. So I won't go as far of a fix as this. I'll just point out the mistakes here. So trim silence from the beginning. You start with a counter, but you don't declare what type of variable this is. The shorthand that we had talked about earlier, that was just shorthand on a post-it note. You still have to follow the rules of Java. And that's declaring what type of object this is before you start using it. Okay. Then you're using a single equal sign. That's assignment, and this needs to boil down to a Boolean statement. So true or false, because as long as while needs a condition to run this code. And so this needs a double equal sign, which will turn into a true or false. Then the count goes up. That works. Over here, before you can use the new, that needs to be on the other side of an equal statement. Well, not all the time. No, so that's, but in this instance, yeah, this has to be put somewhere. So you want to create some variable called like new song or something to that effect. So you just declare a new array that's shorter, and you can find out how to declare a new array. We already talked about that. So once you do that, then you need to copy the values from the old array to this new array. So this is a 0, this is a 0, this is 0. So you get 4, and then you get one that's not, and so it stops the loop, but you've counted up to 4 at that point. So start a for loop, start at count, and then go up until the length, and then each time you say, hey, new array, whatever name you give it, your value at, well, this would be at wherever you're at here minus the count. So your value at I minus count, which would be 0 on the first one, is equal to samples at I, or whatever you use in your for loop. I makes sense because it's the index. So I usually try to use I. And then, so just translate that over. And then, this works. You can totally just write samples or this.samples equals, and then give it the name that you give here. The new array works fine. And what that does is this is pointing to an address in heap memory. So you're just saying, hey, instance variable named samples, class variable named samples, you now point to this new array. And so you'll have two arrays pointing to the same place. And this other one will be orphaned, and garbage collection will come pick it up and throw it away, so it's not, your private data isn't sitting in your RAM waiting for a hacker to steal. But that's fine, because now it'll be updated to this new one, and pointing at that. Cool. And just technically, once this method closes down, then this new array is then orphaned and collected by garbage. Because all of the variables, including count, all get trashed, and garbage collection will take care of it as soon as this method closes. And that's some of the security that you get through Java and many languages.